Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So today we will start the module 5. Okay, so in this we will see the problems on direct stress distribution. In this case, what happened earlier we had seen, but individually. So in this case, first including both axial constraint and elementary bending stresses. So in this question we will see both when will be there, then what happened. Okay, so let's see. So lecture topic is problem on direct stress distribution, including both axial constraint and elementary bending stresses. So just see here the question. Calculate the direct stress distribution, again including both axial constraint and elementary bending stress at the built-in end of the cantilever beam shown in figure for the case when W is 0.5 Newton per mm. That uniformly distributed load is given, right? W as 0. Because it's just here Newton per mm. With this we can identify what is that. It's a point load or uniformly distributed load. So here Newton per mm means it's a uniformly distributed load. That you can see here in the figure W per unit length, and that's why per unit length this side is there, right? Unit mm. Next, L is given as 1500 mm. So from here to here that L is there, right? This L is 1500. Okay, H is given as 200 mm. So this H is 200 mm. T is 5 mm. Thickness is given as 5 mm. So here is the thickness. So it's just given as 5 mm. And E by G ratio is 3. Now what we have to do, we have to find the direct stress distribution by keeping in mind that both axial constraint as well as elementary bending stress. So let's see, here these things are given: a cantilever beam, then W equals to 0.5 Newton per mm, L equals to 1500 mm, okay, H equals to 200 mm, D equals to 50 mm, T equals to 5 mm, and E by G is 3. So these are the given data. So now just see, as we know that torsion bending is what? TR, that is equals to T into H square into dq by 24. So directly we are using here, because again we cannot derive. Now we are in the numerical, so directly we are taking the formula. So T equals to TH square in dq by 24. And as we know, the rate of twist is what? D theta by dz equals to A cos mu h plus B sin mu, A cos mu z plus B sin mu z plus WH by 2GJ into L minus Z, right? So this is our rate of twist. Now just what we have to do, we have to find the A and B. This is the general solution of the differential equation, right? So now what we have to first find A and B and then substitute back, then we will get the value of D theta. So for that, first what we will do, just applying the boundary condition. So when Z equals to 0, what happened? D theta by D, Z also will be equals to 0. So W equals to 0 and Z equals to 0, which gives, so after substituting here, what? Z0 and D theta by dz as 0. So just see here what we will get. So D theta by dz equals to 0, right? This equals to A cos H mu into 0, because Z is 0, plus B sin H mu into 0 plus WH by 2GJ L minus Z is 0. So 0. So now this is sin 0. So sin 0, 0. So this total term remains. Now cos 0 is what? 1. So what we have, A plus 0 equals to A plus WHL by 2GJ. So from here what? A will be equals to minus WHL by 2GJ. So just see here. A equals to minus WHL by 2GJ. So now we have the value of A. Now we will apply the second boundary condition to find B. What is that? When Z is equals to L, D theta by dz square equals to 0 and sigma equals to 0 at Z equals to L. Then substitute in equation 1 again. So after substituting, when Z is equals to L, okay, D theta by dz. So again, now from here what we will get? B equals to WH, after substitute, B equals to WH by 2GJ into L tan H mu L plus 1 by mu cos H mu L. So now this is the value of B, this is the value of A. Now we have A and B, substitute here. Then we will get the value of d theta by dz. So just here, substituting A and B value in equation 1. So after substituting, what we will get? D theta by dz equals to WH by 2GJ into minus L cos H mu Z plus mu L sin mu L into sin mu L plus 1. So this is argument of this one, that mu L plus 1 by mu cos H in mu L into sin H mu Z plus L minus Z. So after substituting the value of A and B, we got this one as rate of twist, right? D theta by dz. Now from the formula that sigma t is what? Minus 2ARE into d theta by dz square. So now this is d theta by dz, right? So now what we require? To find d2 theta by dz, because this is the formula for sigma t. Once we know the d2 theta by dz square, we can directly substitute here. So what we have to do? First differentiate this equation, because this is d theta by 2. What we require? d2 theta by dz square. So differentiating this one. Okay. So after differentiating this, what we will get? So just see here, d2 theta by dz square, okay, equals to, this is constant, so just keep this one, WH by 2GJ. Okay, now inside we have to differentiate. Okay, so L cos H, cos H differentiation, sin is to mu, differentiation of this is will give mu, so mu L sin H, so minus mu L sin mu Z for this one, plus, now for this one, mu L sin mu L, right? This is constant because here Z is not there, so this plus is constant, so this whole thing is constant because here H is not there. So mu L sin mu L plus 1 divided by mu cos HL, this whole thing is constant, and then differentiation of sin mu Z is cos mu Z, so into cos mu Z plus differentiation of L is 0 and differentiation of Z is minus 1, right? So just see here, this we got after differentiating. So what is that? Differentiating equation 2 and substituting in equation 3. So after differentiating, just substitute here, right? So after that, what we will get? Minus 2ARE and this value, differentiation of d2 theta by dz square. So finally what we will get? Right, sigma t equals to minus 2ARE into WH by 2GJ into minus mu L sin mu Z plus mu L sin mu L plus 1. This whole into divided by cos mu HL into cos H mu Z minus 1. So this is the value of sigma t. Okay. Now at the built in when Z is 0. So now put the value of Z here as 0. Right. So let's see here, two term is there when Z is 0. So after substituting, what we will get? That term will be, this term will be 0. Right. And here after putting this, what we will get? Cos mu into 0. Right. So cos 0. Cos 0 will give you 1. So this becomes 1. So what is left? This term. Right. And minus 1. So this into this term minus 1. Right. So let's see here. So after putting Z equals to 0, what we got? Sigma t equals to minus 2ARE WH by 2GJ. Okay, into mu L sin mu L plus 1 minus cos after taking LCM. So this is, or in simple way, let me solve first this one. Okay, so now we are putting Z equals to 0. So here this will be what? Sigma t equals to minus 2ARE WH by 2GJ into, so this one minus mu L sin H mu into 0 plus mu L sin mu L plus 1 divided by cos H mu L into cos mu Z. So cos mu into 0 minus 1. So this mu naught 0 will be 0, right? Because this mu into 0, 0, sin 0, 0, right? Similarly here, so sin, this is cos 0 as 1. So 1 into this term. So now what we have? That sigma T equals to minus 2AR EWH by 2GJ, okay, into this one mu L sine mu L plus 1 by cos H mu L minus 1. Right. Now take the LCM. So after taking LCM, what we will get? So after taking LCM, we will get sigma T equals to minus 2ARE WH by 2GJ into, so this will be the LCM, cos mu H L, and this gives mu L sine mu L plus 1 minus cos H mu L. Right, that is there. So this is here. That means after simplifying, we got this one after putting at z equals to 0. Now evaluating the constants, means simply just putting the values. So tau r is 1040 into 10 to the power 6 m power 6. Z equals to 12500, that is 12,500 mm power 4, and mu square equals to 4 into 10 to the power minus 6. So mu L is 3. Okay, that is already the y ratio that is given. Now, so after substituting this value here, right, just substitute all the values here, right, then sigma t will be equals to what? Minus 0.025 into 2AR. Okay, now here, so for finding sigma t, what is required? That we have to find 2AR value. Okay, how we can find the 2AR value? So just see here. The distribution of 2AR is linear around the section, so far sigma tau is also linear. Since 2AR is linear, so sigma tau also, so sigma tau is also linear at 1. So from there, 2AR equals to minus h into d by 4. Okay, now we know the value of h, we know the value of d. So find 2AR. So 2AR equals to h, how much is given? So minus h d by 4. So just see how much h is given. So minus, let's see here the value of h. H is 200 mm and d is 50. Right? So minus 200 into 50 by 4. So this will give you 250. Right? So 2AR is 250 minus 250. Right? So now put here. So after putting in this one, so what we will get? Sigma t equals to minus 0.025 into minus 250. Right? That sigma t equals to what? 62.5 Newton per mm square. So now we got sigma t at 1 as plus 62.5 Newton per mm square. Okay. Now for symmetry of 2AR distribution, for symmetry of the 2AR distribution, that time what happened? Sigma tau t3 will be equals to sigma tau 1. So sigma, that is equals to sigma tau 4. So from here what we add? That also equals to sigma tau 6. So from here what we will get? Sigma 1 is plus 62.5 Newton per mm square. Right. Now sigma tau 1. So sigma 3 is what? Sigma tau 3 is minus sigma tau 1. So that is minus 62.5 Newton per mm square. Now sigma tau 3 over. Sigma tau is what? So sigma tau 4. Okay. That is equals to how much? Sigma tau 4 is equals to sigma tau 1. Tau 4 is equals to sigma tau 4. So that's why that is 62.5 Newton per mm square. And sigma tau 6 is minus sigma tau 1. That is minus 62.5 Newton per mm square. This is from the symmetry. And sigma tau 2 and sigma tau 5 will be equals to 0. Okay. So now this we got. that all the value of sigma tau 3, sigma tau 1, sigma tau 2, sigma tau 7, sigma tau 1, sigma tau 2, sigma tau 3, sigma tau 4 and sigma tau 5 and sigma tau 6. So all the 6 value of sigma tau we got for all the sites, right? Now, okay, so what is the next formula is sigma z is equals to my into x divided by I y y. So sigma z. So now, so first let's find my, that moment, right? So 0.5 into 1000 square divided by 2, right? 0.5 and the here. Weight is given 0.5, right? But what we require weight per unit length. So we require load into perpendicular distances moment. So once we will multiply 0.5 into 1500, this we got as load, right? So load into perpendicular distance. So first my is load into perpendicular distance. So load is how much? 0.5 Newton per mm is there. So 0.5 into length per unit length is there. So that length is 1500. Okay. So this is the load into perpendicular distance where it will act at the center it's acting. So perpendicular distance is how much? 1500 by 2. So after, so my from here after multiplying what you will get 562500 Newton mm. So this is my. Now next what we have to find my we got now Iyy. So next let's find Iyy. So Iyy will be equals to what? So BDQ by 12 is there, but here 2 symmetry section is there. So 2 into BDQ by 12. So 2, B is 5, D is here 50 because along that axis only we are finding divided by 12 to 6 star. So after calculating what we will get 104200 mm power 4. So this is the value of I. Now sorry I y y according to along the Iyy we are taking, that's why this here D is 50 and B is 5. If along Ix it will take, then 50 into 5 cube will be there. So but we are finding Iyy, so that's why now just substitute these two values, that is Iyy value and my value here. Then what we will get? Sigma z equals to, after putting and simplifying, sigma z equals to 5.4y. Now once we know the value of that, because x is here y, so once we know the value of y, we will get the sigma z value. So sigma z is 5.4y. Now, so whatever is there, so just see here 5.4 into this one. Okay, so that is sigma z1 equals to plus 135 Newton per mm square. So from the symmetry, what we will get? Sigma z1 equals to minus sigma z3 equals to minus sigma z4 plus equals to sigma z6 equals to 135 Newton per mm square, and sigma z2 and sigma z5 equals to 0. So just here. Okay. So the complete direct stresses. So this is, let's see, that's why that combined one is there. So now in this case, what happened? The complete direct stresses are sigma 1 equals to what? Just addition of sigma tau 1 and sigma z1. So just add sigma tau 1 and sigma z1. Then we will get what? Sigma 1 equals to 190 plus 197.5 Newton per mm square, which is also equals to minus sigma 3. Sigma 4 will be equals to what? 62.5 minus 135, that gives minus 72.5 Newton per mm square, and that also is equals to minus sigma 6. And sigma 2 and sigma 5, that is equals to 0. So just see here this step, because what is mentioned there both we have to find, right? So till this we found individually sigma tau and sigma z. According earlier what we found, that sigma either sigma tau, answer is over. In another problem sigma z, problem is over. But in this case when both are combined, okay, then what happens? So according to the axis of symmetry, that first we have to find separately sigma tau and sigma z, and after that what we have to do? We have to just add right, with direction. Whatever the value you are getting, that value, okay, then you will get the value of sigma 1 to sigma 1, sigma 2, sigma 3, sigma 4, sigma 5, and sigma 6. Okay, so like this. So means here this step you have to just take care. Okay, so just see quickly once again. The cantilever beam is given and all the dimensions is given in figure, just like W is 0.5 Newton per mm, L is 1500 mm, H is 200 mm3, D is 50 mm, T is 5 mm, and this one. So for this figure, we have to find all the values is given. So this is the given data, right? So now from the torsion bending you get what? The tau r is TH square dq by 24, right? That is this one. So now first we will find the rate of twist, and from there we will start. So the rate of twist is what? This formula we know after solving the equation, the differential equation, we got this one. So d theta by dz is a cos mu z plus b sin mu z plus wh by 2gj into L minus z. So this is d theta by dz. Now here what is that? We have to find a and b. For finding a and b, what is required? Put the boundary condition. So after substituting the boundary condition, what is that? Z equals to 0, d theta by dz is 0, right? So when z is 0, w is 0, and that is d theta by dz is 0. So which gives, so after substituting here, you will get the value of a equals to minus wh L by 2gj. Now we got the a. Now what we have to do? We have to find b. So how we will find b? When z equals to L, right? d2 theta by dz square is 0. So sigma is 0 at z equals to L. Then equation. So after substituting in this equation, what we will get? B equals to this we get. Now substitute a and b in equation 1. Okay. So after substituting in equation 1, what we will get? This is the final formula. Right, not formula. So means after substituting in a and b in equation, we got this one. Right. So now we have d theta by dz value, that rate of twist. But what we require to find sigma? So that sigma tau is what? Minus 2ARE d2 theta by dz square. So for substituting in this equation, what we require? d2 theta by dz square. But what we have? d theta by dz means what? Differentiate this equation. So after differentiating, just substitute here. So see, differentiating equation 2 and substituting in equation 3. What we will get? Sigma tau is this one. Now we have the general sigma tau formula. Now depending upon sigma 1, sigma tau 1, sigma 2, whatever the condition is given, just based on that, substitute here. You will get the value of sigma tau 1, sigma tau 2, like that. So just here. Okay. So at the built-in int, when z is 0, right? Then sigma tau is what? Minus 2ARE wh by 2gj into mu l sin mu l plus 1 minus cos mu l cos h mu l by cos h mu l. So now this we got. Now in this only we have to substitute where tau r is 1040 into 10 to the power 6 mm6. Okay. Z as 12500 mm power 4, mu square as 4 into 10 to the power minus 6, mu l is 3. Right. Just substitute these value here. What will get? Sigma tau is equals to minus 0.025 into 2AR. Right. So after substituting this value, what we will get? For this whole thing, we will get minus 0.025. Okay. And into, sorry, this plus and minus 2 is there. So minus 2AR. Now, what is required here? We have to find the AR value. From the figure, AR will be equals to what? 2AR equals to minus HD by 4. Now just put here that HD by 4. So now this formula becomes sigma tau equals to what? Minus 0.025 into minus HD by 4. Now H is given 200, D is given 50. Just substitute. You will get sigma tau 1. Right. So that's all. Now here you have to just apply the symmetry formula. Right. So for symmetry, what symmetry will be there? Just see here. Sigma tau 3 will be equals to minus of sigma tau 1, or you can say tau 1, right? So sigma tau 1 we know, sigma tau 3 is minus of sigma tau 3. That is equals to minus of sigma tau 4, right? So means sigma tau 1 equals to sigma tau 4 you can say, or sigma tau 1 equals to minus sigma tau 6. That gives what? Minus 62.5 Newton per mm square, right? And sigma tau 2 and sigma tau 5 will be equals to 0. So now sigma tau we found. Now next is what? We have to find the sigma z. Right. So we know sigma z is what? My into x by Iyy. So here x is y, right? X is equals to y. Now we have to find my. My is what? Force into perpendicular distance. So force is what? 0.5 per length, right? Per unit length. So 0.5 into 1500. This is weight into or load into perpendicular distance. So 1500 divided by 2. So you will get my. Now next is Iyy. Iyy is 2 into bdq by 12. Both the side is symmetry. So for simultaneously both. So after multiplying, you will get 104,200 power 4. Now just substitute these two value here. So after that you will get sigma z equals to 5.4 y. Okay. Now, so that is from here sigma z1 equals to plus 135 Newton per mm square. From the symmetry, sigma z1 equals to minus sigma z3 equals to minus sigma z4 equals to sigma z6, that is equals to plus 135 Newton per mm square, and sigma z2 and sigma z5 is 0. Right. So now we have sigma tau 1 to tau 6 and sigma z1 to sigma z6. Now the complete direct stresses will be what? Sum of sigma tau 1, that is sigma tau plus sigma z. So add. So after adding, sigma 1 will be sigma tau 1 plus sigma z1. So it's a 62.5 plus 135. That is plus 197.5 Newton per mm square. That is equals to minus sigma 3. Sigma 4 is equals to sigma tau 1 minus sigma z1. So 62.5 minus or just with plus sign. Whatever is there with the plus value, just add, you have to both. So you will get minus 72.5 Newton per mm square. That is equals to sigma 6. Sigma 2 and sigma 5 is 0. Right? So now this is the final answer. Okay. So this is the reference, that is from again THG Maction. Right. So if you have any doubt for this question, you can just refer to this book or you can just comment on the video so that I will rectify that doubts, or you can just directly contact me regarding your doubts. I will clarify that doubts. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.